we will learn about nuclear fusion versus nuclear fission process. Before going to start, if you are new to my channel, please subscribe my channel and press the bell icon for upcoming videos so that you will get the notification. So let us start today's class. So what is nuclear fusion energy? So we can call these such kind of processes as nuclear reactions, nuclear fusion reaction or fission reaction. So first we will understand nuclear fusion energy. Okay. When very light nuclei combine to form heavier nuclei, in such a process we call that as a fusion. So we can come across here lighter nuclei will combine and they will give heavier nucleus. So that's why it is called nuclear fusion. So nuclear fusion is the energy producing process taking place in the core of the sun and stars. This process only occurs in sun or stars in their core. So these processes naturally takes place in such kind of celestial bodies, or we can call it as sun and stars, but on earth it is not going to occur. So we have to build nuclear reactors for that. So we can understand with the help of this reaction. So when tritium, deuteron and neutron, these are the lighter nuclei, they will fuse together to give the nuclear fusion energy. Okay, so here lighter nuclei, all these kind of lighter nuclei, they will combine to give a heavier nucleus. So they will produce energy. That energy we will call it as fusion energy. So this is the example for nuclear fusion reaction. Since nuclei are positively charged, because nucleus consists of proton and neutron, so electrons always revolve around the nucleus. So that's why we call nuclei are positively charged. They need to overcome the Coulomb repulsion barrier before they can fuse. If these such kind of lighter nuclei will fuse, they are having the similar kind of charge, then they must come this repulsion. If two like charges are there, they will repel each other. So that Coulomb repulsion they have to come across if they fuse together in nuclear fusion process. So that's why the huge amount of energy is required for nuclear fusion. The temperature is very high. It is of the order of 10 to the power 7 Kelvin. At that temperature nuclear fusion process is possible. So the sun, as we know, on the surface or the core of the sun, the temperature is very high. That's why this process naturally occurs in sun. That's why the sun produces energy through this process by set of reactions. There are two kind of reactions that are responsible for nuclear fusion, that are called proton chain reaction or carbon nitrogen reaction. So nuclear fusion energy is several times greater than fission energy. So the energy released per chain reaction is greater than the nuclear fission process. So now let us understand nuclear fission. Fission means breaking, fusion means combining. So what is nuclear fission reaction? So nuclear fission is a reaction in which the nucleus of an atom splits into two or more smaller nuclei and releases a very large amount of energy. Okay, it is quite opposite to the nuclear fusion. Okay, here heavier nucleus will split into two lighter nuclei. So we can understand with the help of this example. One of the good example is uranium. So if uranium nucleus, or we call a target nucleus, that hit by a projectile, that is neutron, then this nucleus of a heavier atom that will split into, that will become unstable by interacting with the neutron. We can say this is the unstable nucleus. Then that unstable nuclei will produce two lighter nuclei that are called fission products, along with three neutrons. So such kind of processes are called, or such kind of reactions are called nuclear fission reactions. So this is the example of uranium. Uranium 235, the mass number, when it is incident by the neutron, that is projectile, then two lighter nuclei are formed, that are krypton having the mass number 90 and barium having the mass number 143. So along with three neutrons. So this is one of the best example for such kind of reactions. Usually radioactive elements are unstable nuclei, so they are useful for such kind of reactions, nuclear fission process. So in this table we can clearly observe the difference between nuclear fission and fusion. So nuclear fission is the process by which an atom's nucleus breaks into two lighter nuclei during a nuclear reaction. So nuclear fission, in this process of nuclear fusion, two or more lighter nuclei collide to create a heavier nucleus. So second difference, we can see a significant amount of energy is produced when each atom divides, and that if we compare with nuclear fusion is the process that is going to produce several times more energy or more powerful than nuclear fission. So comparatively, as we said, less energy is needed to split an atom into a fission reaction, but here heavy amount of energy is required to join two or more atoms. Nuclear fission reactions do not take place in nature, and fission process can take place in nature, but that only to stars and sun. Nuclear fission is the basis for operation of an atomic bomb, and whereas fission is the basis for hydrogen bomb operation. So this is all about the nuclear fission versus nuclear fusion. So please like, share and subscribe my channel if you found this video helpful. So thank you for watching.